Assalamu alaikum. Good afternoon, everyone. This is week 13 and 14, csf4203, chapter 16, WAN Services. When you want to, imagine that you are network administrator or you are the CIO of one company, and you need to decide on your WAN strategy. So what are the things that you need to consider or you need to think about? What are these things? Okay. Of course, you need to think about the architecture of your network. So you need to be able to have a good architecture to support your business applications and your communication requirements. And also you need to consider which one technology and service you can implement and is available for you to choose from. Okay. So these are the both considerations. There are some WAN alternatives such as the dedicated channel service, which includes T1 and T3. T1 and T3, by the way, is used in the US. In Europe, they have E1, E2, okay, E3. This was the most common leased line for high traffic voice. Also, frame relay. Frame relay, of course, is a switch network technology. The frame relay protocol can be used over a dedicated line to provide a convenient multiplexing technique. We have also the public switch services, which includes dial-up modem. The advantage about it is it's inexpensive, but it will provide you low speed, the modem. Then in organizations, of course, dial-up modem is not enough, so many LANs and private branch exchanges are equipped with modem banks to provide low-cost supplemental data transmission service with the modem bank. So multiple modems functioning together. These are examples of the integrated network strategies. So here you have, this is an integrated network access using public switched WAN. Okay. The first one is integrated network access using dedicated channels. As you can see here, here you have your own dedicated channels for your company. And for the second one, they are going over the public switched WAN. An obsolete technology, or now nobody is using it. Of course, it's legacy. Nobody is using it. The X.25, but still we need to mention it. It determines the user network interface. The key features about X.25, it was based on call control packets used for setting up and terminating virtual circuits, and are carried on the same channel as data packets. And here the multiplexing takes place at the third layer, at the internet layer or network layer. Okay, and both layer 2 and 3 include flow control and error control mechanism. That's why it was very slow. But by the way, this used to be used by banks. So this results in considerable overhead, and it is therefore it is not suitable for modern communication, digital communications. Frame relay, on the other hand, we already studied frame relay. It was designed to eliminate much of the overhead of X.25. Nobody is using X.25. Okay. The key differences or key advantages of frame relay is frame relay supports multiple connections over a single link. It supports call control signaling is carried on a separate logical connection from user data. That's why it's more efficient. Multiplexing and switching is done on layer 2 instead of layer 2 and 3. Okay. So this is eliminating one entire layer of processing. There is no hop-by-hop flow control and error control. The virtual circuits and frame relay connections. So here we have packet switching. In the normal packet switching, each virtual circuit carries control and data. Okay. In frame relay, each virtual connection carries only data with one exception. There is one LAPF connection used for control signaling. The others, they are used for data in frame relay. That's why frame relay is efficient. Congestion control. How does frame relay deals with congestion control? We have two methods. We have congestion avoidance. Its procedures are used at the start of the congestion to minimize the effect on the network. And there is the congestion recovery procedures. It's used to prevent network collapse in the face of severe congestion. Okay? So two methods, congestion avoidance or congestion recovery procedures. That's why we use the BECN and FECN bits. Okay, BECN and FECN bits. BECN means backward explicit congestion notification. It indicates that the frame, the user, it transmits on this logical connection may encounter congestion resource. Okay. Forward indicates that this frame on this logical connection has passed through or has encountered congestion resource. This is very good feature about frame relay, by the way. And it will tell you whether there was congestion before it arrives, or it will tell you if there is going to be congestion ahead, backward or forward. Okay, this sometimes come in the exam. What is the difference between BECN and FECN? In case it's not clear there, I think maybe the text is not coming clear here. I'm gonna write it, type it here. Okay, this is the BECN, and this is the forward explicit congestion notification. So it's a bit. It's a bit. Okay, next. Asynchronous transfer mode, like ATM. It is similar in concept to frame relay, but it was developed to achieve higher speeds. Okay, faster than frame relay. It is called also cell relay, and of course it is much faster packet switching than X.25. It can support data rates several orders of magnitude greater than frame relay. We know that. Okay, we have virtual channels and virtual paths. Virtual channels in ATM is actually logical connections. It is analogous to virtual circuit X.25 or frame relay data link connection. And this is the basic unit of switching in ATM network, the virtual channel. The virtual path is actually a bundle of virtual channels, which have the same endpoints. All of the cells flowing over all of the virtual channels in a single virtual path are switched together. That's why the ATM is very fast and efficient. This is how it looks like. This is the connection relationship. Here you have the physical transmission path, the media. Here you have your virtual path, and inside the virtual path you have your virtual channels. Okay. Advantages of virtual paths. It is simplified network and architecture, increased network performance and reliability, by the way, and reduced processing and short connection setup time. This is all achieved by the virtual paths. Also, it is enhanced network services also. Let me put it together here. These are the advantages in case the slide is not clear. Then we have a new technology. It's called MPLS, multi-protocol label switching. It is IP-based networking service. It is designed to speed up the IP packet forwarding process while retaining traffic management and QoS and ATM. Okay. And it can carry many different types of traffic, by the way, the MPLS. Very efficient. MPLS-enabled routers can coexist with ordinary IP routers. It is also designed to work with ATM and frame relay networks. Okay, it can work in parallel. Has the potential to completely replace frame relay and ATM. It is actually doing that. Okay. This is the MPLS. Okay, you can have ordinary IP routers and you can have the MPLS routers. We call them label switching routers, LSR. Okay. Here you have your MPLS domain. This is the MPLS label format. So you have a label value, and then you have the traffic class, which is TC, and you have S, which is the bottom of stack bit. And then you have time to live. This is your MPLS label format. For the wide area Ethernet, this is a technology based on delivery of WAN services using Ethernet connectivity. We know that Ethernet was used for LAN, but why we can also use it for WAN. So we call this WAE. It can provide high speed to traditional WAN services, and it maintains the simplicity, high bandwidth, and flat network of layer 2 Ethernet. So it's simple to understand. Essentially a VPN service for linking remote locations. Okay, these are all advantages of WAE. Sometimes they call it Ethernet WAN or carrier Ethernet. So they are all the same. The use of carrier Ethernet technologies to create metropolitan area network is most commonly called Metro Ethernet. Also, they call it Metro Ethernet. Okay. So Metro Ethernet is based on WAE. This is a wide area Ethernet. This is the core network. And then you have your, it's connected to your carrier Ethernet switches. Then we have the cellular wireless network. And this is one of the most revolutionary developments in telecoms. It supports users in locations that are not easily served by wired networks. It's used for mobile telephones, personal communication systems, wireless internet, and wireless web applications, and more. Okay? Of course, this is your cellular wireless networks. Now we have 5G providing very high speed over mobile. This is how it works. This is the cellular system. Here you have your mobile. It will communicate with the base transfer station or BTS, and the BTS will communicate with the mobile telecommunication switching office, and this one can communicate with the public telephone switching network, then it can communicate with the landline. Okay? You see the route your call will go through if you are calling a landline. These are the different generations for mobile telephony. First generation, it was analog, and it was using frequency modulation. Second generation, it started using digital techniques and time division multiple access, TDMA, or CDMA, code division multiple access. It used advanced call processing features. Okay. The third generation, it evolved from several second generation wireless systems. The fourth generation, it currently is being also used, but in some places they are being replaced by 5G. Let's talk a little bit about third generation, 3G. It was intended to provide high-speed wireless communication, mainly for multimedia, data, and video, in addition to voice. Okay? It was using TDMA or CDMA to utilize the spectrum. The 4G was more efficient. It was all based on IP network, IP packet, and it was supporting peak data rate of 100 megabits per second. Okay, and 1 gigabits per second for low mobility access. It dynamically share and use the network resources to support more simultaneous users per cell. It was more efficient, of course, than 3G. It was a revolution in mobile communications. It supports smooth handovers across heterogeneous networks, and also it supports QoS, or quality of service. These are the differences between 3G and 4G. You find here that, of course, 4G is using higher frequency from 2 to 2 gigahertz for the frequency band. The network in 3G, it is wide area cell based. In 4G, it is wireless LAN plus wide area. The services, 3G is based in CDMA. 4G is using WiMAX LTE Advanced. Of course, the peak upload rate in 4G is 10 times faster than the 3G. The download rate in 4G can reach up to 1 gigabits per second. Switching technique, 3G is based on packet switching and circuit switching. 4G is all packet switching. This is the third generation. You can see here the fourth generation is using these WiMAX or Wi-Fi towers. Okay. So you can see the difference here. Satellite communication, because some areas are remote, you cannot reach them with wire. So it is good to make advantage of satellite. It is using a satellite-based antenna, which is orbiting the Earth in a stable orbit. In a satellite communication, 2 or more stations on or near the Earth communicate via 1 or more satellite that serve as a relay station in space. Yani one location is sending to the satellite. From that satellite, then it will send it to another location. Okay? Because the satellite is rotating around the Earth. Okay? So for the people who are under the satellite, it is like if it's fixed. Because we are all rotating. It's rotating with the Earth. You understand? Some of them like this. The transmission from Earth station to the satellite is called uplink. The transmission from the satellite to the Earth station is called downlinks. The transponder in the satellite takes an uplink signal and converts to a downlink signal. So the transponder is located where? Inside your satellite. So transponder is a device inside the satellite. We have different satellite communication configuration. We have point-to-point link. You can see here satellite, and it's sending to one location. Here is sending, then it relays it uplink, downlink, one location to one location. The other one is broadcast link. So here you have transmitter is sending to the satellite antenna, and the satellite antenna is broadcasting it to other locations. The most important applications for satellites are television distribution, satellite radio services, long distance telephone transmission, private business data networks. Any questions? This is the last slide for this chapter. I'll stop here and just take your questions. Do you have any question about this part?